So the one last thing we can do with the mean and standard deviation is that we can look at individual observations to see if they're outliers or to compare people from different distributions using what's called a z-score. And z-scores are almost always on the first exam. So there's two different types of z-score questions. Well, three. There's always a conceptual one, but there's also then having you use z-scores to either identify outliers, that's number one, or compare values, that's number two. Number three is just sort of maybe a true-false about this sort of idea about what the heck a z-score actually tells us. So our calculation for a z-score is given here. This is actually a calculation I will give you on the exam. I will give you this version of it. So if you feel comfortable using those variables and understanding what they mean, then you're fine for the exam. You don't need to write this on your note card. Remember, mu is the mean for our population. It looks kind of like an M, so that's not that terrible. And sigma is our standard deviation, and that looks kind of like an ugly S, so hopefully we won't have any trouble there. And then X is one observation that we are trying to see how far it is from the mean, because that's what our z-score tells us, how far away from average something is. So, as I said, z-score represents how far above or below the mean we are, and it technically means how many standard deviations away we are. So we're going to figure out how far away is it, and then divide by standard deviation, so we can say it's 2 standard deviations above the mean, or 2 standard deviations below the mean, depending on whether we have a positive or negative z-score. So if it's a really large z-score, that's sort of a hint that we're dealing with something unusual, which is why we can use it to evaluate outliers. So as we saw with the empirical rule, within 3 standard deviations, we have 99.7% of our data as long as our data is normally distributed. And so if something is outside of 3 standard deviations, if we get a z-score out of like 3.1, we know that this is in the most extreme values because it's in that 0.3%. So we can use z-scores to see if something is unusual. Now, the cutoff for unusual can vary. Some people will use a z-score of 2 because, remember, based on the empirical rule, that's where 95% of our data is. So again, pretty dang unusual if you're outside of that 95%. But it doesn't, like, this is a little arbitrary for now. We're not going to have a hard cutoff. It's more likely on a test that'll ask you to figure out which is more unusual for 2 different values, so that you're looking and comparing apples and oranges more than you are just doing this for one and saying, oh yeah, this is a super unusual value. So we have one example here. This is actually stolen from when I was at my job at UCSD. We had some crazy blood glucose levels that we could not say were errors, and so we tried to identify whether or not they were outliers using z-scores. So turns out blood glucose levels are normally distributed with a mean of 85 and a standard deviation of 5. So again, if we have a mean and a standard deviation, we actually know a lot about this distribution, especially because we have that sweet keyword of normal. Would a patient with a blood glucose level of 68 be considered unusual? All right, so we're going to use z-scores to see whether or not this is unusual, like this section says. So we're going to use our formula, x minus mu over sigma. X is the observation. This is the thing we actually want to test. So how far away is 68 from what we expected, right? We expected a mean of 85, so this person has a very low blood glucose level. But how low is it? Well, that really depends on the standard deviation, how much spread we expected within our data set. So if we divide that by 5, we'll be able to see a little bit more of what's going on. Oops. I didn't know I got switched back to tablet mode. So I don't have any calculator with me, so I have to actually pull this up and do it. 85. Oh, by the way, this is a common mistake. You do not want to type this into your calculator like this. The calculator knows the order of operations. It will divide the 85 only. So if you're going to be lazy like I'm being and not use parentheses, then do this in 2 steps. So we get negative 3.4. So this means that 68 is 3.4 standard deviations below the mean. It is crazy unusual. Yes. A blood glucose level of 68 is over 3 standard deviations. Blah. Below the mean. Now this question does ask us to redo all of this work with 98. We can hopefully see 98 is not nearly as far away from 85 as 68 was, but they're just asking to redo this exact same calculation with 98 instead. Which is 1 point. I can't do math in my head. Well, who am I kidding? I'll just do this in my calculator. Like, dividing by 5 is really not that bad, but I just can't do it. 2.6. So, again, this would depend on the criteria for 98. 2.6 is still dang unusual. It still will get cut off by every single one of these other criteria. This would be considered an outlier. Based on the standard 3 standard deviations, not quite. So like I said, on the test, I'm either going to give you something that's very obviously an outlier, or it's going to be comparing 2 different things and saying which one is more unusual. And so more unusual, and this is the one note you might want to have, more unusual is equal to further from 0. That is not how you spell further. So in this case, negative 3.4 is further from 0 than 2.6 is. All right, so we're going to see another way to use z-scores in the next video.